All right, we're going to continue to talk about simplifying expressions with exponents. So as you can see right here, today's topic is going to be power to a power. Before I move down there, though, I want to remind you of what we've looked at so far. We've talked about how whenever we simplify with exponents, we're going to have a 5-step process. And we're going to have that flow map to help us to make sure that we're meeting that proficiency and we're hitting each of those steps to make sure we're completely simplified. So we have learned so far that anything raised to the 0 power is 1. We've skipped step 2 and learned that we always fix negative exponents. When they move or travel, they lose their negative. So if they're on top, they lose the negative when they travel to the bottom. When they're on the bottom, they lose their negative when they travel to the top. Only exponents, not numbers. And we've learned that we can multiply same bases if we add exponents. So looking at today we're going to talk about what happens if you have power to a power. Power being another word for an exponent. So in other words, what happens if you have not one exponent, but 2? Well, let's look. What does this mean? Well, this square on the outside means to multiply by itself twice. So that would give me x cubed times x cubed. And what is the meaning of x cubed? Well, x cubed means x times x times x times x times x times x. Putting that back into exponential form, I get x to the 6th. Well, what could I have done with 3 and 2 to get that 6? Well, I could have multiplied 3 times 2 to give me the 6. That's our new rule. Whenever we have 2 exponents, a power to a power, we will multiply our exponents to get same base, and then again that multiplication between our exponents. Say, for example, on this for this first example, I have x to the negative 7 raised to the 6. Multiplying negative 7 times 6 gives me x to the negative 42, or 1 over x to the positive 42. So, before I uncover anything else in our flow map, I want to remind you of something. I want to remind you of how to solve when I have a binomial being squared. We spent a lot of time last unit looking at this. What happens when I square a binomial? Well, it means to write it twice. And then some of us like to think in terms of FOIL, others of us like to think in terms of distributing. Either way, I do x times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is another minus 2x. Minus 2 times minus 2 is a positive 4. I combine my like terms and I get x squared minus 4x plus 4. So, when I had a binomial squared, I wrote it twice and FOILed or distributed it out. That is not going to change. However, we do have another rule that tells us if we have a monomial being raised to an exponent, we can distribute the exponent. So I'm going to write that out because that's very important that I know the difference. If I have a binomial squared, I am going to write it twice, and I'm going to say FOIL. If you don't use FOIL, please say distribute in your notes. And FOIL. If, on the other hand, I have a monomial squared or raised to any exponent, that's when I'm going to distribute the exponents. Okay, very important that I know the difference between binomial versus monomial, very different strategies. So let's look at this first example. So notice that in this first example, remember before even that binomials and trinomials are determined by separation with plus and minus signs. Since I don't have any plus or minus signs, I know that this is a monomial. So I'm going to take that 4 and I'm going to distribute it in. It's going to distribute to the 3, the x cubed, and the y. So I will have 3 to the 4th. Well, x cubed to the 4th, remember what we just talked about. What do we do when we have a power to a power? Well, we multiply. So I get 3 to the 4th And actually, you know what? I'm not going to write that as 3 to the 4th. I can figure out what that is. 3 times 3 is 9. Times 3 more is 27. Times 3 more is 81. Because in math, if I can do it, I want to do it. And I can do 3 times itself 4 times. So I get 81, x to the 12th, y to the 4th for my final answer. So now let's put that into our flow map. So I've uncovered step 2. So after I look to see if I have anything raised to the 0 power, I'm going to distribute my exponents into my monomials using the power to power rule and multiplying. I'll fix negative exponents by moving the base, and then I'll multiply same bases by adding. So looking at this first example, I notice that step 1, I don't have anything raised to the 0 power. Moving to step 2. I do have parentheses, so I can distribute that square. I'm going to distribute it to the 5, the x to the negative 4, and the y to the 5th. When I do, I'm going to leave the top alone, so let me actually write that really quick. When I do, it becomes 5 squared. Negative 4 squared is going to be x to the negative 8, because with power to power I multiply. And y to the 10th. Moving along my flow map, now I'm going to fix negatives. So I'm going to take anything that has a negative exponent and I'm going to move it. When I do, it's going to lose its ticket, so that y to the negative 2 is going to move, and x to the negative 8 is going to move. Notice I'm not moving my negative number, just negative exponents. And that's going to give me negative 3 x cubed 4 x to the 8th, because that negative 8 loses its ticket, 5 squared y to the 10th y squared. Well, now I need to multiply same bases. Well, could I multiply the negative 3 and the 4? Aren't those just numbers? And the commutative property tells us it doesn't matter what order we multiply in. And x squared and x to the 8th, those are same bases, so I can multiply those together and add my exponents. I can square the 5. I know 5 squared is 25. I had to memorize that. Y to the 10th and y squared, those are same bases. So I'm going to end up with negative 12 x to the 11th, 8 plus 3, 25 y to the 12th for my final answer. Let's look at another example. So notice that I rewrote or re-put on my flow map, so I can use that again because I'm always going to use my flow map. So first thing I do is I check and see, is anything being raised down here in example 3? And this would be a good one. This is the last example if you wanted to pause it and try it on your own as well. Okay, so checking to see, I do have something being raised to the 0 power. This whole thing is being raised to the 0 power, so this whole expression is going to become 1. So I'm going to have 1 times x cubed y to the negative 3 z all to the negative 3 over 2 x to the 4th y to the negative 2 z all cubed. I'm going to change colors. I think this green is kind of funky. From here, I've now done step 1. Step 2, I'm going to distribute. So I'm going to distribute the negative 3 into everything, and I'm going to distribute the positive 3 into everything. Notice this times 1 isn't necessary, so I'm going to lose it. When I distribute, I lose my parentheses. So I'm going to get x to the power says multiply. Positive 3 times negative 3 is negative 9. Y to the negative 3 times negative 3 is positive 9. Z, 1 times negative 3 is z to the negative 3. On the bottom, doing the same thing, I get 2 cubed. Don't forget that it also distributes to the numbers. Distributing to the x, 4 times 3 is 12. Distributing to the y, 3 times negative 2 is negative 6. And distributing to the z, I get z cubed. From here, I'm going to go ahead and look at my flow map. I've now, whoops, I don't need to write all over it. I've now went ahead and distributed. Now I want to fix my negatives. So there's just a couple I'm going to move. I'm going to move my x, my z, and my y here. And when I do, they will lose their negative, and I'm going to lose a little bit of my flow map so I can fit it all on the same screen, but I'm just losing the steps I've already done. I get y to the 9th and y to the 6 all over 2 cubed x to the 12th, z to the 3rd, and then x to the 9th comes down, and z to the 3 comes down. Now moving on to step 4, I'll multiply same bases. Y to the 9th times y to the 6th is y to the 15th because I add the exponents. 2 cubed, well 2 times 2 is 4, times 2 more is 8, not 6. Remember, you have to multiply it by itself. X to the 12th and x to the 9th, 12 plus 9 is x to the 21. And z cubed times z cubed is z to the, adding again, 6th. So there would be my final answer. That is going to be our first 4 steps for simplifying exponents.